This is my explain the material assignment, and I'll just get right into it. The question tells us that one of these four functions will open downward at the vertex 2, 5. I have that noted up here. And to figure out which one of these opens downward at which one of these parabolas opens downward at the vertex 2, 5, we could just put it into a graphing calculator, but that wouldn't make for a very good video, so we're going to do it the long way instead. But if we were to put it into a graphing calculator, we would see that y equals negative x squared plus 4x plus 1 is the correct answer. And I'm going to convert this into vertex form to show you that it is the right answer. So I have it rewritten down here. Y equals negative x squared plus 4x plus 1. So the first thing we notice is there is a negative 1 in front of the x. We need to get rid of that. So to start, let's factor out all the x's, isolate them into y equals quantity negative x squared plus 4x plus 1. And now we still need to get rid of that negative x. So we need to multiply everything in the parentheses by negative 1. When we do that, we get y equals negative 1 times quantity of x squared minus 4x plus 1. And so you can see we got rid of the negative in front of the x, but in doing so, the 4x became negative because the sign switched from up here. So that is our new equation. But now we need to get the AC term in right here, because right now we have the A term and the B term, but we still need to get a C term. So to do that, we need to half the square. We need to do something called completing the square. That's what it's called. To do that, we need to take the B term, in which case negative 4, divided by 2. So negative 4 divided by 2 equals negative 2. Now we need to square that. So negative 2 squared equals negative 2 times negative 2. That equals 4. So we need to plug this back into our equation. That leaves us with this. Let's put that there. So we have, but since we all putting this on the same side of the equation, we need to add a negative 4 and a positive 4 and a negative 4, because that way it stays in balance, since this is on the same side of the equation. So this is what our equation now looks like. Like I said before, we needed to put that plus 4 to get a standard form. But we also need to put the negative 4 to keep it in balance, since this is all on the same side of the equation. But this right here, we need to keep this in mind, because we are multiplying everything by a negative 1. And since this is a negative times a negative, which would just look like this, this is a positive now. So a negative times a negative equals a positive. So that positive 4 plus 1 will leave you with a 5, which is where this 5 came from. We need to multiply that negative by this negative. So that 4 plus 1 equals 5. That's basic math. So this is what our equation now looks like. Y equals negative 1 times the sum of x squared minus 4x plus 4. All that is added, all that plus 5. So now we need to factor this. To do that, we know that in our factored equation there will be an x, because this x is squared. So we know that there will be an x. So x plus or minus something times x plus or minus something. Now to figure out what we need to plug in here, we take whatever we got when we divided negative 4 by 2. that was obviously negative 2. So put negative 2 here. Again, we're doing a negative 2 because that's what we got when we divided the b term, negative 4, by 2. Now we could simplify this even further into x minus 2 squared. So we now have y equals negative x minus 2 squared plus 5. And that is in vertex form. If you were to plug that into your graphing calculator, you get the same thing as if you plugged in y equals negative x squared plus 4x plus 1. So that is how you convert something into vertex form when a is a negative 1. And there you go.